So I'll talk about trust and I'll talk about security in general. So my name is Philip Verlooy. I'm the field CTO for a startup called No Name Security. We focus purely on securing APIs. Having said that, I won't talk about no-name security too much, so I'll mainly spend the next 25 minutes or so talking about information security in general, of course API security, and then I'll do a quick wrap-up specifically on no-name and how we look at things. So if I sort of take a step back and look at IT security or information security in general, it's often thought as the department of no, right? It's not really delivering any sort of direct business value, at least not from a business point of view. So the way that I look at security is I compare it to a meerkat. So if you look at a meerkat, there's typically a group of about 20 or so meerkats that live together. And the function of the meerkat is to build burrows and to gather food and to compete with the neighboring meerkats that sort of live in the same territory. If you think about APIs, it's sort of similar. If you build APIs, you want to monetize APIs, you want to deliver performant APIs, you want to do interesting things like, in the case of Janssen this morning, you want to think about curing blood cancer, for example. Having said that, one of the meerkats is the sentinel meerkat. It's the security meerkat. Its only function is to sit up straight all day and look around for predators. And if he sees something, he or she sees something, he signals to the rest of the group, they immediately go underground and they burrow in. So the idea is that without this sentinel meerkat, building burrows and gathering food doesn't lead to anything because they will be eaten, right? So that's the same way I think about information security. It might not seem like it's delivering any business value, but without it, you're sort of dead in the water, especially when it comes to APIs, which by nature want to be externally accessible. A couple of speakers already mentioned this morning that there's no difference between an internal and an external API. Like over time, all APIs sort of become externally accessible. Now, if you think about the business and what the business cares about at a deep level, I mean, if you ask like a C-level executive at a deep level, like what do you really care about? Like forget about what the tagline on the website is, like what do you worry about? It's typically three things. It's making money, it's saving money, and it's avoiding risk. Those are the three things they think about every day, all day long. So if you think about security, of course it falls into this bucket of avoiding risk. So to some extent it is important, but you really have to think through what risk really means. So if I define risk from an IT security perspective, I define it like this. So what is the likelihood something will happen? And if that something happens, what would be the impact to my business? That's how I classify risk. Sometimes the business needs a little bit of a triggering function. Like sometimes they forget that the risk is there and something needs to wake them up. So one example is this breach at Uber in September. So somebody breached Uber. They got access to all of this internal data. They started posting some of that data online, which included expense reports of VPs. They really don't like if you publish expense reports of VPs on the public internet. So what we see here is that the breach happened on September 19. Consequently, all of a sudden, a day later on LinkedIn, they had all of these new security functions open at Uber. So all of a sudden, the business was awoken to the fact that if I think about making money, saving money, avoiding risk, security all of a sudden got higher on the list, and people started to take notice. So sometimes we need this forcing function in the business to think about security. Now, being a CISO is a tricky job. So the CISO of Uber specifically, he already has enough problems. So Joe Sullivan, the former CISO of Uber, he was involved in a data breach in 2016, where there was a lot of personal data exposure, but they didn't disclose it. Like they decided to hide it from the public. Of course, at a certain time it became public, and now he's being indicted and he will probably go to jail. So being a CISO is not an easy job. So if you think about IT security and breaches, or let's say security incidents and how they sort of happen, especially how they happen initially, there's only 5 ways in which security breaches happen initially, I think. If you know more, happy to discuss over some drinks after the session, but I think there's only 5. So there's unpatched vulnerabilities, there's security misconfigurations, there's weak, leaked, or stolen passwords, there's social engineering, and there's insider threats. So I, as a CISO or as the VP of security or whatever, if I think about my risk matrix, this is how I build my risk matrix. Of those 5 things, what is the likelihood one of them will happen? What would the impact be to my business? And that's how I sort of look at risk. So if I have those 5 things, where do my APIs fit into this picture from a security perspective? That sort of becomes the thing to think through. Now, somebody this morning didn't agree with the fact that data was the new oil. I sort of agree with that statement, like data might not be the new oil. I think the term was actually coined in 2006 by a UK mathematician, and really what he meant to say was, data is like oil in that it needs to be refined into gas and petroleum to have any real value. But anyway, we sort of all say data is a new oil these days, and from a term of APIs, what it means is if you want to do something interesting with data, or more and more even carrying data between systems and between an end consumer and a backend system, happens on the basis of APIs. So APIs are really becoming the pipelines of transferring data between people and more also between systems. So as an attacker, I'm really going to hone in and focus on attacking the pipeline, because those are, at least today, more exposed than most of the backend systems themselves, because again, by their very nature, to some extent, they need to be exposed in order to be operational, in order to be useful to the business as a whole. So one example I have here is Optus. So Optus in Australia, a telco carrier, was breached not too long ago. I believe they lost about 10 to 11 million PII records of their customers. The back-end reason was, we're not 100% sure, but due to some investigative journalism, especially by this gentleman here, they sort of found out that it was due to an unauthenticated endpoint, an unauthenticated API endpoint. Not only was it unauthenticated, the way that users were identified in the backend was a simple number that just counted up with 1. So you could just enumerate the entire list of customers very, very easily without having to authenticate. So this is a typical broken object level authorization attack, or an insecure direct object reference type of attack, which happens all of the time. Now, APIs, another sort of property of an API is that everything becomes interconnected, or it's easier to interconnect everything, which is a fantastic thing, but from a security perspective, it's also a challenging thing to some extent. One example, which I also found on Twitter, is this gentleman here who logged into his bank account. He is not even an Optus customer, but he got a pop-up saying, please destroy all of your ID cards because you're probably hacked in the Optus breach. So all of these things become interconnected. So Australia is quite far away, but it also happens more close to home. So this is a recent example from the 1st of December in the Netherlands. So this is FVD, het Forum for Democratie, which is a political party. It's the biggest political party, apparently, in the Netherlands. So what they did is they built an app called the Forum app, which talked to their backend through an API. But they forgot to sort of implement basic security. So what you could do is you could read all of the PII information by directly talking to that backend API without any authentication, and get all the user information, personal details, first name, last name, where they lived, account numbers, telephone numbers, So a really pretty bad breach. And of course, it also included former members of this political party. And I'm sure some of the people wouldn't like their name to be publicly known, being a member of that political party. I have no judgment about the FAD, but I can imagine some people wouldn't like it to be publicly known. So this keeps on happening. Again, if we then think about risk and API security specifically, it is our thesis, and that's why we started the company, that the likelihood an API breach will happen is very high. The impact is very, very high as well. So the risk is really, really significant. So that's why we sort of focus on API security specifically by integrating into your existing security control toolset. And I'll explain a little bit more about that in a second. Another thing that comes into the picture is this concept of super apps. So in the previous session, you heard about the KBC app, which now apparently includes links to Jupyter or something. I'm not a KBC customer, so I don't know. I am, however, a Belvius customer. So within Belvius, if you log into the mobile app, you can also pay for your mobile parking through B-Mobile or 4411, as it's sort of known in Belgium, which is it's great. So it makes it really, really easy. So it's nicely integrated into my Belvius app. I park somewhere in Brussels, and I can start my parking clock and be on my way. Now in Belgium, we have this famous hacker called Inti de Keukelaar. So what this gentleman found out is that 4411 is like a sieve, like it's leaky. So what you can do is all these number plates, if you drive up to a parking garage, get registered in a database sort of automatically. And if you know what you're doing, you can read out that list of license plate numbers. Now, think about being the Minister of Justice in Belgium. Your license plate is a matter of public record, so anybody can look up your license plate number. There's threats against you as a Minister of Justice. They can see where you're parking if you're driving into a parking garage. So this becomes really potentially a bad situation in the actual metaphysical world. So all of these things are interconnected, if you like it or not. All right, so this sounds bad, but how do you take a bad situation and make it even worse? You introduce Elon Musk. So what Elon Musk is trying to do with Twitter is trying to build the super app of super apps, right? So he said, like, if you look at China, China has WeChat, and the Chinese people, they live on this app. So everything that they do, social interactions, payments, everything works through this WeChat application, which is essentially a combination of different applications that plug into this single app, and together form this platform, or this ecosystem, maybe, if you want to call it like that. So we are on this path of going to build this super app as well, all on the basis of API integrations, of course. So we really need to take a step back and think through what the potential implications might be for building these systems. Some of these super apps already exist today. So if you use Uber, so I travel constantly around the globe. I'm never home, but in certain countries, I can already use my Uber app to pay for my public transport. So I can use local public transport, look it up through Uber, through the Uber app, and pay for it through the Uber app. So we're seeing already these integrations happening. So we spoke about FAD, we spoke about Optus. There's many, many more examples that exist. So I won't list them all. But of course, these are sort of publicly known. You can look them up. The Coinbase one is super interesting. It's also from this year, from February, where if you had a dual account in Coinbase, you could actually switch between accounts mid-transaction and sell a coin you didn't own. So super interesting business logic error in the trading API of Coinbase. We did our own independent research as well. So we hired this a former hacker called Alyssa Knight to do some research on 55 mobile banking apps. None of these were Belgian banking apps, but 55 Belgian apps across the US, Canada, also neobanks, so non-traditional banks, banks that only exist on the internet, basically. And what she figured out is that all of these applications are vulnerable to a certain extent. Most of them use hard-coded API keys or tokens inside the app to talk to the back-end systems. This is, of course, problematic. If you think about the city of Antwerp today, which is under a cyber attack right now, so I'm sure if you watched the news the last couple of days, there's a ransomware gang called Play. They stole 550 plus something gigabyte of data from the city of Antwerp. There's bound to be tokens and API keys in that data set somewhere. Thinking through a public services organization like the city of Antwerp, I'm sure they have links to federal databases. Maybe they can read ID cards and so on. So I hope somebody is cycling the API keys on those applications. Otherwise, we're all going to be in trouble. I happen to live in Antwerp, so if you say, I don't live in Antwerp, I don't care. Last night, the city of Diest was also breached. It keeps on happening. So who should fix this problem? And that's a good question. So if you think about APIs, who is involved in building APIs, right? So you have developers who create the applications, you have developers who create APIs, you have the product teams who productize APIs, you have the network security team, you have the application security team. There's a lot of people who are involved in building and potentially securing APIs, so it's not an easy ask, like who has the ultimate responsibility for making sure these APIs are secure. That also translates into the actual technology stack that we see today as well. So if we go to a customer, we typically find a variation of this, right? So you have your backend APIs, you have your front-end APIs, there's a gateway in between, there's a web application firewall in between, and then you deliver your APIs out to the external world somehow. There's many, many people involved in configuring a web application firewall, configuring a gateway, and there's developers looking at things like coding best practices, maybe linting, maybe looking at API governance. How do I implement the rules that I've created using my open API specification and so on? There's static application testing, dynamic application testing. So there's a lot going on. So if you then say from a high level down, because there's breaches in the news, and the CIO calls a meeting with all of his department or her department heads and says, we need to secure our APIs. Good luck. So if you think about developers, we talk about shift left a lot, right, in our industry. So if you think about developers, turns out, and this is from a survey called Secure Code Warrior, so I stole this from an AWS session recently, where it turned out that only 14% of developers list security as a top priority when writing code. So yes, developers are responsible, but they might not think through security in the way that we want them to. So if you then look at bugs in the code, so this is a study from the mid-80s by Jim Gray of Tandem. So Tandem famously had this fault-tolerant system that could never break. And when it broke, Jim Gray, who was a hardware engineer, said, I think it's the software, and I'm going to prove it's the software. So what he did is he looked at the reason why his system broke, and then he found out that when the engineers call code complete, there's one bug per 10 lines of code. When it then goes to QA, there's one bug per 100 lines of code. And when it then goes into production and gets some iteration going, it goes down to one bug per 1,000 lines of code. Now, of course, you're going to say, this is the mid-80s, nobody did agile development yet. These old people don't know what they're doing. I'm from the mid-80s, I can say this. It's still true. So this is a book that's a couple of years old now, Applied Software Measurement. And they looked at when are bugs introduced in the code. So of course, most of the bugs happen during initial coding, 85% plus. And then during testing, we'll find more and more of these bugs. Now, what it looked at specifically is what is the cost of fixing this bug? So of course, if we can fix the bug during coding, the price is 1x. You're going to fix it while you're coding it. If it goes all the way into production, it actually costs 640 times as much to get it out of production and fix it post-production. So that's why, as an industry, we're now sort of pushing heavily on shifting left. Problem with shifting left is that we're pushing too much left. So we're asking developers to not only think about monitoring, observability, security, testing, everything shifts left. So if you want to do that, we have to make it as seamless as possible. If you want to shift API security testing left, it has to be completely automated. Otherwise, it will fail, in my humble opinion. So if you then think about all those people who are responsible, application security, network security, who is responsible for building secure APIs, then ultimately the question is, yes, everybody is responsible for building secure APIs. That's the problem. So talking to customers, all of our customers already have an API gateway and already have a web application firewall, and that's where we want them to be, right? You need these tools in place to give you that base level of security control as a good starting point. What an API security platform is attempting to do is to take a step back and provide that additional context. So not only do you see what the web application firewall sees, meaning only the APIs that flow through the application firewall, but you see all of the communication, east, west, north, south, internal traffic, external traffic, partner traffic, et cetera, and that's when you can start to put the pieces of the puzzle together. It's not only us saying that. There's Gartner and OWASP sort of saying the same thing. The main problem with these inline security tools is the following. You have a rules-based system trying to defend against a logic-based attack. That will never work, because we cannot predict the logic of the attacker. We simply cannot. So a rules-based system, what it will do is it will look at the transaction, it will validate the transaction against its rule-based, and it will say yes or no. What happens with an API attack, it's a low and slow attack. So people do all of these calls to different endpoints and try to figure out how far can we go in the chain, and that's why it goes undetected. When I talk about API security context, this is a very quick example. As a human, we don't have to think about this. As a human, we get this, right? So as a human, if I look at the method, the hostname, and the path, I understand that if I'm reading twitter.com v2 users all, that is very different from deleting twitter.user.all, right? A more difficult example, if I'm posting to useracceptance.twitter.com, I know it's different than posting to twitter.com, right? So as a human, I understand this. But as an inline security tool, it's very hard to see that context. Furthermore, we've spoken about this before, pre-production versus production, the different ways in which you secure these systems. Maybe pre-production, you're using like SAML-based authentication. Production, you're maybe doing OAuth. At a certain point, your pre-production API will escape into production, and now we have a problem. So these things keep on happening. Additionally, what we like to do in IT is we like to come up with our own standards. We like standards, and then to a certain point, then we don't like them anymore, and we come up with a new standard. That's typically what we do. We spoke about GraphQL in the morning. So if you compare REST versus GraphQL, REST for each piece of functionality typically has a different endpoint. GraphQL is one big endpoint, and depending on the query, you get a different piece of data and a different result back. Push that through a firewall and see what happens. Your firewall will cry. So how do we fix it? And now, so this is the no-name security bit. I'll go really, really quickly. So the way that we look at things is we want to give you an inventory of all of your APIs because we believe everything is a brownfield. Like there's already APIs in production, you have to account for those as well. So we integrate with the vendors you saw today already, like Axway, different gateways, different web application firewall vendors. We just integrate them, feed the traffic into our system, and provide that additional API security context so you can see exactly what's happening with your APIs, what data is flowing, who is using them, how many people are talking to them, what is the infrastructure that's powering them, et cetera, et cetera. We generate the context by looking at those 4 things. What is the actual production traffic that's going to the API? What is the code behind the API? How have you documented the API? And does the documentation different from the production traffic? And where are you powering your APIs from? The previous example, everything ran in Azure. That gives us a lot of context about what's powering those APIs. The third step, and the second to last step, is to learn intent. So what I said before with if you have a rules-based system and you're trying to block a logic-based attack, you're running into some difficulty. And what I mean by that is we don't know the intent of the API. Every API is unique. That's what's make them powerful. So we have to understand by looking at the quote-unquote good users, how they are using your API. That teaches us how the API is supposed to behave. So that teaches us intent. And then we can validate against a malicious user who is doing something completely different outside of the norm. Of course, under the hood, this is machine learning and black magic. So we can then differentiate against that baseline of normal behavior, and then we will say thumbs up or thumbs down, yes, this transaction can pass, yes or no. So that's really the idea. And the final step then is to act. So once we've detected this, again, we're going to integrate with your API gateway, with your web application firewall, with your existing tool set, and ask those systems to block on our behalf. So that's really the nice thing here is you don't have to replace anything you already have. If you look at the API, the OWASP API Security Top 10, number 1 issue is BOLA. That's those 2 examples I looked at. So this is what a BOLA detection would look like in our system. Just to sort of reiterate the point. So what the system is saying here is that a normal user only talks to his own object ID. So we can match the user ID with the object ID that the user is querying. This particular user here is querying 8 different object IDs. So that's why we know that this is not a normal user. We have learned this is bad intent, and that's why we're saying this user should be blocked.